All right, so welcome back to the Civil FE exam review. In this video, we are going to be starting the dynamics section, and we're going to be looking at basically different parts that are moving. You're going to be dealing with a little bit of physics. You're going to be dealing with speeds, energy, work, acceleration, force, all of that stuff. And your body, these bodies and these different parts are going to be in motion. So with statics, things were kind of still from like a point of view where, if you have static friction, right, something's not moving, right, everything's staying still. But with dynamics, we're going to be moving a lot more. So we're going to start with kinematics. And so I have a few practice problems for you all, and I want to go ahead and dive right into it. All right. So number one says, a car is moving with a constant velocity of 20 meters per second for 30 seconds. Calculate the displacement during this time, right? All right, so let's take a look at this. So first things first, we want to write out our givens. We're given that we have a constant velocity. Let's use a different color. Make this interesting. All right. That is 20 meters per second. And then we're also given a time. All right. Calculate the displacement during this time. So we want to find displacement. Judging from my units on the answers, my unit should be in meters. Okay, something to note. And are there any formulas needed, or is the handbook needed? Well, just thinking about this rationally, right? If I have something, a car, draw a little car for you guys. Little car. Oh, I hope you like the high wheels on this thing. It looks like a shoe with some wheels on it. All right. And so if I know that this thing is, if I know that it's moving, say it's moving that way at 20 meters per second, and I know that it's doing this constantly for a time of 30 seconds. So really, if I know that it's doing this for 30 seconds, then I know after 30 seconds, it should be moving after 1 second. So if I did 20 times 1 second, right, it would only be moving 20 meters. But if I did 20 times 10 seconds, it would be 200 meters would have moved, right? But this question asks for 30 seconds. So each second it is moving 20 meters. So 20 times 30 gives me, and these units, notice that these units cancel, and we're just left with 600 meters. So this really wasn't super complicated, right? Nothing did really trick you up. But you do need to know, you do need to make sure that your units are correct, right? So this answer is going to be D. All right, let's look at number 2. Number 2 says a train starts from rest and accelerates at 2 meters per second squared for 10 seconds. Calculate the displacement during this time. So this is a little different. All right, so what information are we given? Well, we're given the acceleration, which is 2 meters per second squared. We are given the time, and we're trying to calculate the displacement. Now displacement, I really didn't go over this in the first one, but displacement is the difference in distance from point A to point B. So in our previous example, all right, displacement, we were starting at, we say 0 meters, and after that 20 seconds, we landed at 600 meters. And this car is on this, journey. And the displacement is that distance along that time, right? So displacement just means distance. Okay. So I could even take it even more detailed, like this is 0 seconds, and then this was at 30 seconds. And so we could say at 15 seconds, this is approximately the displacement from where it would be. Okay. All right. Hopefully that makes sense with my shoe example. Okay. So for this one, all right, we're given acceleration, we're given time, we're trying to find displacement. So is there a formula that I can use for this? So first thing is, it would be nice if since we're in dynamics, right, section, if we go to our bookmarks, we can select dynamics. All right. And for these type of problems, right, I know that we're studying kinematics. And so let's see particle kinematics come through. Just doing kind of a quick scan. But typically the particle rectilinear motion is typically what I go to for most kinematic problems. So you need to be familiar with the symbols, because you're not going to know what's going on if you don't. So I know that, so if you're not familiar with the symbols on the exam, the first place to look is here. So S stands for a position coordinate. Like S0 would be the initial position, and regular S is the final position. Same as for T. If there's a T sub F, that would be the final time, and then T sub 0 is the initial time. So sometimes these are put in a different place. So acceleration is represented by A, V is represented by velocity, but we're trying to calculate the displacement. And anytime you're trying to calculate displacement, you need to be looking for S typically, because it's a position or a distance from an origin, right? So if I know that my if I know that my train starts from rest, I know that my V0, or my initial velocity, is equal to 0, right? And I also know that my T is equal to 10 seconds. Now my acceleration is equal to 2 meters per second squared. And I'm trying to find so I know my initial, my S is 0, which is the initial distance. It's going to be 0 because it starts at rest, but my S final is equal to question mark, because I don't know what my final is. So based on the information that we have, how do we determine which of these formulas are going to help us to determine the final distance, or S, right? Well, let's walk through them, right? V is equal to V0 plus A0 times T. So do we have our initial velocity? Yes. Do we have our final velocity? No. Are we trying to solve for final velocity? No. Do we have A0? We know that A0 is 2 meters per second, and we have our time. So if we were trying to solve for final velocity, then this one would be a good one, but we're not. Okay, let's go to this one. All right, we have S final, right? That's what we're trying to solve for, so that's fine. S0 we have, which is 0. Do we have V0? Yes, we have V0. It's going to be our, is 0 in this case, 0 meters per second, because it's at rest to start. We know our time. That particular time is, our time is 10 seconds. 1/2, okay. A0, we know that to be 2 meters per second, and T is going to be 10 seconds. So it looks like there's only one unknown in this equation, and it's the unknown that we need to use and to solve, or it's the unknown that we need to find. So this seems like a good one. I want to go through one more. Let's just look at this one, right? So V final squared, right? Do we have V final? No. Are we trying to search for V final? No. Do we have V initial? Yes. Do we have A0 or acceleration? Yes. Do we have S0? Yes, we do. Do we have S final? No. So this one has 2 unknowns. So however we plug our answers in, we cannot solve for an unknown because, you know, it doesn't give us an answer. So the best equation to use is going to be this one, right? So let's write it out. S is equal to S0 plus V0 times T plus 1/2 A0 T squared. Okay, perfect. All right, so let's plug these in. S is equal to 0 plus 0 times 10 plus 1/2 times our acceleration, which is 2 meters per second squared, times what's T? 10 seconds. And we're going to square that. Pay attention to our units, right? So I know that this cancels, 0 times 10 is 0, 0, 0, right? If we do 10 squared, that's 100, right? That's 100 seconds squared, times 2 meters per second squared times 1/2. Right? So notice these units will cancel. That cancels. And so you should just be left with 100 meters. And so that's very important that your units make sense, right? So the distance or the displacement over this 10-second period is going to be 100 meters. So our answer is A. Okay. Number 3. It says an object is dropped from a height of 40 meters. Calculate its velocity just before it hits the ground. Okay. Let's see. So the given information is we have an object. Basically the displacement. We know the displacement is 40 meters, right? It seems like that's about it. And then we want to calculate the velocity just before it hits the ground. So we know we want to find the final velocity just before it hits the ground. All right. So from this information, right, if you have this block or an object, right, and here's the ground, and let's say you're in your little tree house. Yeah, like my tree. And you're out here and you can walk up into the cliff and the object's gonna drop down, right? So what information does this tell us? Right? So you got to know that from this, what's going to be acting on this object? Well, first of all, we know that our initial velocity is equal to 0 because when you're holding the object, the initial standpoint is you have to be holding it. So it's not going anywhere. Now, do we know V final? No, that's what we're trying to search for. Right before it hits the ground. Do we know time? No. Do we know acceleration? We do. We know that the acceleration is going to be 9.8 meters per second squared. Our acceleration is gravity, right? If you just let something fall, gravity is going to accelerate it, and that's what gravity is. It's 9.8 meters per second, so squared. So that helps a little bit. We also know that it's this distance from here to here is 40 meters. So we know our initial distance is our initial distance is 0 and our final distance is equal to 40 meters. All right. So going back, solving for final velocity, right? We do not need time necessarily. We're solving for final velocity. So this is the one that we are looking. That's what we're looking for. All right. So out of our equations, all right, V final. All right, how do we get V final? Okay, so do we have final velocity? No. Okay, do we have initial velocity? Yes. Do we have an acceleration? Yes. Do we have time? No. So there's 2 unknowns here. Next one. Do we have S final? Yes. Do we have S initial? Yes. Do we have V initial? Yes. Do we have time? No. Okay. So this one would allow us to solve for time. Let's see if there's a better one. But if not, we could solve for time and then use that to then input this in to, now we wouldn't have two unknowns in this other equation, right? But see if there's any other ones that we can use. So we got, do we have S final? Yes. Do we have S initial? Yes. Do we have V initial? Yes. Do we have V final? No. Do we have time? No. So this one is two unknowns again. So these first three don't seem very good. Let's see if we can use this last one. So we have V. Do we have V final? No, that's what we're searching for. Do we have V initial? Yes. Do we have acceleration? Yes. Do we have S final? Yes. Do we have S initial? Yes. So using this one, we only have one unknown. Therefore, we can use and just solve for the variable that we're trying to get, which is why we would choose this one. All right, so you could have chose this one, but this one would have given you time, which is not what you're solving for. So you just want to make sure that you're being very efficient with your time and selecting the formula that's going to give you the answer that you're looking for and not add steps. So if you chose this, if you chose to solve it with this equation, great. But this, what you'll find out is this will give you time. From there, you'll have to use another equation and put time into one of these two equations to then get your final velocity, when you didn't have to do that. You could have just chose the one that would have given you your answer on the first step. So this is very important as you're going through and using proper time management. So, all right. So V squared is equal to V0 squared plus 2A0 times S minus S0. Great. All right, V squared is equal to 0 squared plus 2 times 9.81 meters per second squared times 40 meters minus 0 meters. Okay. All right. So for my V or V final, I get 28.01 meters per second. All right. So that concludes kinematics section of the dynamics review. The next section will be looking at mass moment of inertia.